Hey guys, in this video we shall see another problem on LeetCode linked list cycle 2. Given the head of the linked list written whether there is a cycle in the linked list, then true, otherwise it's false. But here, given the head of the linked list written a node where cycle begins. If there is no cycle, written none. So there is a cycle in the linked list if some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to. It is -1 if there is no cycle. Note that POS is not passed as a parameter. Do not modify the linked list. So if we take this example only, 3, 2, 0, -4, and that is cycle to 2. So at first we have to take two pointers. That is, one is slower and faster. Both are pointing to head. And slower equal to slower dot next, and faster equal to faster dot next. So initially both slower and faster are pointing to head, and you perform this until slower equal to faster. Both slower and faster are pointing to head. First slow equal to slow dot next. Yeah. Next faster equal to faster dot next. So first we will point here. Then again the one round is completed. Now again second follow. Slow and faster are not equal. So again you perform slower equal to slower dot next. Then faster equal to faster dot next. That will come again here. So another round is completed. Now whether you check whether slower equal to faster, no, they are not equal. Again you perform slower equal to slower dot next, and faster equal to faster dot next. Hence you can see both slower and faster have coincided here. So that means there is a cycle in the linked list. You can see the cycle. So why are we performing this slower dot next and faster dot next, that have been explained in the previous video. The link have been provided in the description box. You can check that out and come to this again. So now this proved, yeah, there is a cycle in the linked list. Cycle is present. So in the given question, they have asked if there is a cycle in the linked list, return the node where the cycle begins. So if you observe in this question, the node where the cycle begins is 2. So how do we get this node? So to do that, I'll take another example. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So once you have this, let's start with the for loop. Okay? Slower and faster will find it. Slower, faster. So slow equal to slow dot next. It will come here. Fast equal to fast dot next. Fine. Then again you perform slow equal to slow dot next. Fast equal to fast dot next. So yeah, it will go here. So okay, fine. Second round done. Slow and fast are not equal. Again you perform slow equal to slow dot next. Then again fast equal to fast dot next. They are not equal. So again you perform slow equal to slow dot next, and fast equal to fast dot next. So again they are not equal. Again you perform slow equal to slow dot next, and faster equal to fast dot next. So it will point here. Again you perform slow equal to slow dot next because they are not equal, and faster equal to faster dot next. So faster will point here. Again, you perform slow equal to slow dot next, and faster equal to faster dot next dot next. So faster will be pointing here. So they're not equal. Again, you perform slow equal to slow dot next. Done. Now faster equal to faster dot next dot next. So yeah, both you can observe here both slow and faster are pointing to the same point. Hence, you can conclude that there is a cycle in the linked list. So given the head of the linked list, return the node where the cycle begins. So the node where the cycle begins is actually 3. So how do we get the 3? For this, what you have to do is, here it is. Yeah, we have to take another pointer that is pointing to the entry. Let's take it as enter. It is pointing to the head of the linked list, and the slower pointer is pointing to the current value where it is present and where faster and slower are equal. So if you observe, if you perform entry equal to enter dot next will point here, and slower equal slower dot next will point here. Again, you perform entry equal to enter dot next, then slow equal slow dot next. So you can see it's coinciding where uh, there is where the cycle is beginning. So why is this happening? The reason behind this happening is, let's take from the starting till the point where the cycle is beginning, the length is L1. So this length will be L1. And from the point where the cycle begins till the length where faster and slower are equal to is L2. Slow. So if you observe, slower pointer has moved from L1 plus L2 path. So L1 plus L2 path, total path has been, this total path has been moved by the slower pointer, right? Slower dot next till this point it has been moved. And if you see the faster, it has moved L1 plus L2 path, but at the same time it has completed some rounds already in this cycle, because slower is moving one node ahead, but faster is moving 2 times the slower. So by the time slower is moving one node ahead, it's moving 2 nodes ahead. So you can observe here, faster is has completed some 2-3 cycles over here, right? So that means faster has moved L1 plus L2, L1 plus some cycles here, that is NC. Let's take it as NC, some cycles, plus L2. After completing some cycles, it has moved L2 distance. So plus L2, that is moved by the faster node. So here we have got the condition slower equal to faster actually. So if slower equal to faster, that means L1 plus L2 must be equal to L1 plus L2 plus NC, right? Yeah, so here slower is not equal to faster actually. 2 times the slower equal to faster. So faster is nothing but 2 times slower, because slower equal to slower dot next. Faster equal to faster dot next dot next. That is 2 times the slower. So 2 times the slower equal to faster. So 2 times L1 plus 2 times of L1 plus L2 equal to L1 plus L2 plus NC. So therefore we can say L1 plus L2 equal to NC. So from this what you can tell, L1 is equal to NC minus L2. So what does it indicate? NC, let's take one complete cycle, minus L2 means this distance remaining is given. The remaining distance from where faster equal to slower, from that till the cycle begins. One complete cycle minus L2 distance is the remaining distance, that is equal to L1. So hence, if you start a pointer from entry node and a pointer, slower pointer, and increment both one after the other, will converge at a point where the cycle begins. So got the logic. So it's very simple. I shall explain because that diagram looks very messy. 4, 5, 6, 7, 8, 9, and 10. So whole cycle is one cycle, that is equal to L1 plus L2. We have got the result. So here where the faster equal to slower happened. So from this point, so this total length is L2, and from here to here it is L1. So this is L2 and this is L1. This is nothing but this length is called as L1 equal to NC minus L2. This is NC minus L2 length. This NC minus L2 length we have got equal to the L1 length. So if you increment one point here and another entry point here, so both are incrementing, this also increments, again incrementing, again incrementing. So both will point to here it should be, sorry. Yeah. If you perform incrementing of these both pointers, it will converge at the point where the cycle begins. So we shall code this now. At first, we'll check if head equal to null or head dot next equal to null. If that's the case, then return null. If there is no cycle in the linked list, then you return null. If this is not the case, then there are some elements in the linked list. I have to check whether there is a cycle in the linked list or not. So in that case, okay, this head equal to null is empty linked list. Head dot next equal to null means only a single element in the linked list, and of course there cannot be any cycle in that. So yeah, so coming to the next part, you have to create list node slower equal to head, list node faster equal to head, and one more we need list node entry equal to head. So these two list nodes are to find whether there is a cycle in the linked list or not. This entry list node is required to find where the cycle is beginning. So you perform while faster dot next not equal to null and faster dot next not equal to null. So what will you perform? Slower equal to slower dot faster equal to faster dot next. So here we have to check if slower equal to faster. If that's the case, then you have to perform slower equal to slower dot no, yeah, if slower equal to faster, then you have to perform the loop while entry not equal to slower, perform slower equal to slower dot next. Then comes the second one. What is that? Entry equal to entry dot next. So yeah, after for loop you return entry. That's the point at which the cycle begins. If none of these cases happen, then you just need to return null. That means there is no cycle in the linked list. We will run this. Here I have made this. Yeah, it's been accepted. We'll run this and check. Yeah. If you have any doubts, please drop out in the comment section. We'll come up with another video in the next session. Until then, keep watching and subscribe to the channel. Thank you.